Okay, so what exactly is the relationship between power, torque, and gear ratio? Well, in this video, I'm going to unpack for you this little formula here, which shows the relationship between power, torque, and gear ratio. And I'm going to explain each one of these terms so that by the end of the video, you have a full understanding of what happens when you shift gears as you drive. So, let's start with gear ratio. Now, let's come over here and have a look at these two sets of gears. There's a top set and a bottom set. And let's assume that the small gear here is the one that's driving the bigger gear. And down here, it's the bigger gear which is driving the smaller gear. We call the driving gear the effort gear. That's why I have a little E there. So the smaller gear, in this case, is our effort gear. And the bigger gear, which is being driven, is called the load gear. That's why I have a little L there. So our big gear at the top here is the load gear. Obviously, down here it's the opposite. Our effort gear is the big gear and our load gear is the small gear. Now let's also assume that our big gear has got 20 teeth and our small gear has got 10 teeth. Down here it's the opposite. The effort gear 20, the load gear 10. The question is, what is gear ratio? Well, gear ratio, let's write it in black. Gear ratio, GR for short, is equal to the ratio of the number of teeth in the load gear divided by the number of teeth in the effort gear. So our gear ratio is equal to, let's write TL for number of teeth in the load gear. So T with a small l there, divided by number of teeth in the effort gear, let's represent it by TE. So what do we have? In the load gear, the number of teeth is 20. In the effort gear, the number of teeth is 10. So it's 20 divided by 10, which is equal to 2. So therefore, here on top, our gear ratio is 2. What about at the bottom here? Well, it's the same formula, and it's going to be GR is equal to TL divided by TE, which is equal to, well, here our TL is 10. And our TE, the effort gear, is 20. And that gives us half, which is equal to 0.5. Now, let's also talk about something called RPM. That's the term you see here. RPM stands for revolutions per minute. The little e there stands for the number of revolutions per minute in our effort gear. We'll get to that in a minute. But let's talk about RPM. So what happens as the gears are turning here? Well, we have 20 teeth here and 10 teeth here. So if this one completes 1 revolution per minute, this one will obviously complete half a revolution. If this one does 10 revolutions per minute, this one is only going to do 10 revolutions per minute. If this one does 60, this one will do 30. So what formula can we write? We can say the number of revolutions per minute in our effort gear is equal to 2 multiplied by number of revolutions per minute in our load gear. This means that every time this one turns, say, 10 revolutions per minute, this one will only do 5. So we can say 10 is equal to 2 times 5. That's where we get this formula. So now let's divide right through by 2 and see what happens. So we can say when we divide both sides by 2, we finally get RPM L in our load gear is equal to RPM in our effort gear divided by 2. That's going to be our formula there. So let's clear the board here and record it on this other side. So we have RPM load gear is equal to RPM effort gear divided by 2. Okay, now what about down here? What is the relationship between number of revolutions in the load gear and number of revolutions per minute in the effort gear? Well, here we have 20 teeth, here we have 10. So that means every time this one completes 1 revolution, this one will do 2 because the ratio is 2:1. So if this one does 100 revolutions per minute, this one is going to do 200. So what can we write? We can write, where's my black? We can write RPM, the number of revolutions per minute in our effort gear, is equal to half the number of revolutions per minute in our load gear. Because remember, we said if this one does 100, this one does 200. So this one is always half of this one. So that's where we get this one. What about if we divide both sides by 2? What do we get? We get, sorry, not by 2, by half. I'm sorry. So we will end up with RPM in our load gear is equal to RPM in our effort gear divided by a half. But now wait a minute. Here, these 2 was the gear ratio for the top set here. And this half was the gear ratio for the bottom set here. So it looks to me like generally the formula is RPM in the load gear is equal to RPM in the effort gear divided by the gear ratio. That's where we get this term here. RPM in the effort gear divided by gear ratio gives us this one here. So let's record it here on top. So we can say RPM in the load gear is equal to RPM in the effort gear divided by the gear ratio. Okay, so what's the next step? Let's talk about torque. What exactly is torque? Let's clear some space here. The question is, what is torque? Well, torque is simply the turning effect of a force around a certain point. So, and by definition, torque is equal to force times distance. Now, let's illustrate this with a spanner. A spanner would look like this. Here's our spanner, and we want to fasten or unfasten this bolt there. So, supposing the distance here from there is our D. So, what we're going to do, we're going to apply a force F here. Now, the torque of this force around this point here, in other words, the turning effect of this force is equal to the force itself multiplied by distance. So, torque is equal to force times distance. And the unit of torque is the Newton meter. So, Newton meter. Let's take a couple of examples. Supposing our D here, our spanner is actually 20 centimeters long And our force here, we apply a force of 100 newtons. So what is going to be our torque? Our torque obviously is going to be torque is equal to force, which is 100 newtons, times our distance. 20 centimeters is 0.2 meters, which is equal to 20 Newton meters. What if we increase the distance of the length of our spanner and make it 30? Well, distance now is going to be 0.3. If we apply the same force, our new torque is going to be 100 newtons times 0.3 meters, which is equal to 30 Newton meters. So you can see there that the longer the distance for the same given force, the greater the torque. Now, lastly, what's the last term we need to talk about? It's power. Let me clear this stuff first of all. Power generally is given by work done. So power is equal to work done over time. But in terms of the car, our power is going to be torque multiplied by RPM. So for example, if our torque is, let's say torque is 100 Newton meters, and our RPM is equal to 1000 revs per minute, what is our power? The power is given by, like we said, torque times RPM, which is equal to, our torque is 100, and our revolutions is also 100 times 100, which is equal to 10,000. 10,000, what are the units? The units of power are watts, which is capital W. It's written watts. So unit of power is watts. Okay, so now let's get to the juicy part. Let's talk about gear shifting. We are going to shift from this gear ratio to the gear ratio down below here, and we'll see what happens. But let's also remember that the gear ratio we got on top here was 2. So our gear ratio here, GR, was equal to 2. And down below here, our gear ratio, remember, we got 0.5. Let's also suppose that our effort gear here is directly connected to the engine and has got an RPM of 1000. So we can write, let me use black, we can write RPM of our effort gear connected to the engine is equal to 1000 revs per minute. Secondly, let's assume that this engine to which this gear is connected gives out a power of 3000 watts. So power in, the power input of our engine is 3000 watts. Remember, the unit of power is the watt. Thirdly, let's also assume that the power in is equal to the power out. In other words, there is no loss of energy as this power is transferred from the effort gear to the load gear. So we can write power in is equal to power out. Right, but what is power out? Remember we said power, which is power out in this case, is equal to torque multiplied by RPM. But what is this RPM? Is this the RPM of this or that? No, this is on the output side. So this RPM is RPM of the load gear. Now let's feed in the numbers. We said power in is equal to power out. So here we can write 3000 is equal to, do we know our torque? No. T multiplied by RPM load here, remember it's equal to this divided by gear ratio. So it's going to be 1000 divided by what? Our gear ratio is 2. That gives us 1000 divided by 2 is equal to 500 multiplied by torque. So what is torque? Torque is equal to 3000 divided by 500. So 3000 divided by 500 is equal to T, which is equal to 6 Newton meters. So for the torque arrangement here, we are going to get a torque on the load side of 6 Newton meters. Let me just write it here, 6 Newton meters. Now let's shift the gears and come down here. First of all, let me clear the space. Our power from the engine is still the same. Our revolution for the effort here is still the same. So we can now write power out. Remember, it's equal to torque times RPM effort gear divided by gear ratio as before. What are the numbers? Here we have 3000 is equal to T, we don't know, multiplied by, this one is still doing 1000, divided by, what is our gear ratio? Our gear ratio is 0.5, and that gives us 1000 divided by 0.5 is equal to, we get 2000 T. So 2000 T, what is T? T is equal to 3000 divided by 2000, which is 3 divided by 2000, which is equal to 1.5 Newton meters. Now, what's going on here? Here, on top here, the speed was less. What was it? It was 500 revs per minute. Remember, we said our speed would be 1000 divided by 2, which is equal to 500 in the first case here. We got a reduced speed, a reduced RPM, but we got more torque. Down here, the speed was increased. We got 2000. What happened to the torque? We got a reduced torque. So what's happening in the gearbox is that it's a trade-off between our torque and our RPM. If we are going uphill, we want more torque, so we shift to this system here and get 6 newtons because we need more force. When we are going on flat ground, what we want is speed, so we shift to this system here. We get more speed at the expense of torque. That's what gear shifting is all about.